Welcome back, 5th graders. This is Unit 7, Lesson 15, and you can see we are going to use division with two-digit divisors. Just on this page, I want to remind you of some vocabulary. Remember, this number in front here is called the divisor. That's the number you're dividing by. The number you're dividing into is called the dividend. That's this number right here, 476. Okay, and the answer is called the quotient. That would be up here. Okay, let's take a look at the work. Look at where the only difference between two-digit divisor and one, I mean all the steps are the same. They look at how many times does 23 go into 47, and they put 2. 2 times 23 is 46. When they subtract, you get 1. You bring down the 6. How many times does 23 go into 16? 0 times. This step is you need to make sure that you put the 0 there, and then we would have a remainder of 16. Now I know we've learned that we can add a decimal and keep dividing. We also are going to learn how to set that up as a fraction. When we show that as a fraction, we could say our answer is 20 with 16 over 23 left. And again, then we could divide 16 divided by 23, and we could change that into a decimal. So those are some of the things we're going to work on, but mainly just dividing by two-digit divisors.
Alright, boys and girls, on this slide we will be doing some estimation to see what our answer needs to be close to, and then we'll solve for the exact answer. You'll notice that our dividend here is 4 digits, and our divisor is now 2-digit. So we're working with two-digit divisors now, so stepping up our game a little bit. So first of all, to estimate, we have to think about compatible numbers, or numbers that work well together. So for that, I usually use the front number. So if we're looking at the number 79, that would be pretty close to the number 80, okay? So then, when I look at this front number, I look at 8, and I want to think of, okay, what's a compatible number to that that's close to this 4032? Well, I know that 8 and 40 work well together because 8 times 5 is 40, but now I need it to be close to 4032, so I'm going to round that to 4000. Now here, I don't really need to do any work. I can use mental math. So I know that 80 times 50 would give me 4,000. Because if I took 8 times 5, that would give me 40, and then count my zeros, 1, 2 more zeros from both numbers, that would be 4,000. So in that case, I know that my quotient must be close to 50. So as I'm solving, I'll find something that's close to 50. Okay, so now we have to use exact math to find our final quotient. We just know that 50 is going to be our estimated answer, so it's going to be somewhere close to that. So if I look here, I'm going to go 79. I know it doesn't go into 4. 79 is larger than 4, obviously. 79 will also not go into 40, so I put another 0 there. I do know that 79 will go into 403. Now I just have to think, okay, what's going to get me close? Now a lot of the two-digit divisor math is a lot of guess and check. So I'm going to start by taking 79 times 2 and see where that gets me. Because I know it must go in there more than once, but we'll find out. So 2 times 9 gives me 18. Carry my 1. 2 times 7 is 14, plus 1 is 158. Okay, well that's nowhere near 403. So now I need to amp up my guesses. Let's try 79 times 5. 5 is always a good number to use. 5 times 9 is 45. And then 5 times 7 is 35. Plus 4 is 395. Excellent. That's as close as I'm going to get to 403. So I know 79 goes into 403 5 times, because 79 times 5 gets me 395. Now, just like the regular math we've been doing with one-digit divisors, we go ahead and subtract. So I cannot do 3 minus 5, so I have to borrow here. So that becomes 13. So 13 minus 5 gives me 8. 9 minus 9 gives me 0. 3 minus 3, 0. So now, just like in regular long division, I have to bring down the next number to work with. In this case, it's a 2. So now I have the number 82. Well, I know 79 will only go into 82 once. So 79 times 1 would give me 79. Here again, I subtract. And again, I need to borrow. So now I have 12 minus 9, which is 3. And 7 minus 7 is 0. Now, with these two-digit divisors, we won't be getting into decimals, so I would write my answer now as 51 remainder 3. So if I look back at my estimate, I see that my estimate was 50. So I know that my answer of 51 remainder 3 is a very reasonable answer. It makes sense.
All right, we're going to use rounding and more compatible numbers here to try to figure out what number I should use. If I look at 21, I know that's close to 20. And if I look at 1,533, even though that's not exact rounding, I know that's 1,600. Now what that does is that helps me make a good guess of what number I should start with to go into 160, because I know that 20 or 2 will go into 16 8 times, so 20 will go into 160 8 times. So that's probably where I'm going to start. Is I'm going to try 21 times 8. Now be patient, because sometimes those compatible numbers do not work out. So over here on the side, I'll go 21 times 8 is 168. Now because I had rounded this number up, that number is too high. That's going to happen sometimes. So I need to try one number lower. But notice, I'm not going to erase this work, because this might help me in the second round of multiplication. So we're going to go 21 times 7. 7, 147. So I put my 7 above the 3. My answer to that multiplication is 147. And now I subtract. 13 minus 7 is 6. And then the rest are zeros. Okay, next step is to bring down a 3. 21 into 63. Well, I know that 20 times 3 is 60, again using my rounding technique. So again, I'm going to try 3. 21 times 3, probably a mental math problem, is 63. So that worked out nice. And I have no remainder. Now remember, to check your division problems, we can go ahead and multiply our divisor, 21, times our quotient, our answer, 73, and if there's a remainder, we add that. But in this case, there is no remainder, so it would just be 21 times 73, and then you should get the same number as our dividend.
Alright, on this slide I'm also going to estimate to start, and then again solve for the exact answer to see if it's reasonable. You'll also see that estimation, remember, isn't going to give you exactly or very super close to your exact answer. Again, it's just to make sure that you're finding an answer that makes sense as far as where the decimal placement is, or whether or not your number is close to the estimation. So if I look at number 4, I have 3,509 divided by 54. Well, I know that 54 is pretty close to 50. And my dividend here, 3,500, if I think of my front number, 5, I know that 5 and 35 are compatible, because I know that 5 times 7 would give me 35. So I just have to make sure I have the right place. So I'd round that to 3,500. So then I know that 50 times, if I use my mental math, 70 would give me 3,500. Because 5 times 7 would be 35, and then I add my zeros on to the end. So, does this tell me with estimation that I'm necessarily going to say 54 goes into 30,509 7 times right away? Not always. So that's why sometimes estimation doesn't give you the numbers you need to work with. Again, it just gives you an answer that is close to the exact answer. So now I'm going to go ahead and start solving this problem. I'm going to rewrite it so that I have a little more room to write. So if I have 3,509 divided by 54, the first thing I have to look at, does 54 go into 3? No, obviously, it's too large. Does 54 go into 35? Again, too large, it goes in 0 times. Does 54 go into 350? Well, yes, it will. Now I just have to figure out how many times. Now, if I look at my estimated answer, I ideally want a quotient that is close to 70. So, could I try a 7 and assume that that would work there? Possibly. But instead of assuming that it works, I'm going to show the math to try it. So I'm going to use 54 times 7 and solve that first. So 7 times 4 is 28. 7 times 5 is 35, plus 2 is 37. Okay, so that's too high. So there I can see my estimate won't help me now, because obviously it doesn't go in there 7 times. But it's pretty close, so I'm going to try 6. I'm going to go down a little bit. So let's try 54 times 6. 6 times 4 is 24. 6 times 5 is 30, plus 2 is 324. Okay, so that's going to be the closest I can get without going over, because I saw times 7 does put me over our mark. So 54 times 6 equals 324. Here's where I subtract. I'll need to borrow from next door so that I have 10 minus 4 is 6. 4 minus 2 is 2, and 3 minus 3 is 0. Alright, now I'm ready to bring down my next number. In this case, it's a 9, so I have 269. Here's where I need to do some more guess and check. So I know that 54 times 6 gives me 324, so that's pretty large. I need to get to a number that's close to 269. So I already know that 54 times 6 would be too much. What if I try 54 times 4? So 4 times 4 would give me 16. 4 times 5 is 20, plus 1 is 216. Alright, and I know that that's going to be the closest that I get, because if I did 54 times 5, I believe that would go over just a bit. I might just double check to be absolutely sure. 5 times 4 is 20. 5 times 5 is 25, plus 2 is 270. Yep, so it just barely goes over. So I'm going to have to use the 54 times 4. So I know 54 goes in 4 times, and that equals 216. So now I subtract. 9 minus 6 is 3. 6 minus 1 is 5. And there's 0 remainders here. So in this case, I can see that I have no more numbers to bring down. And 54 cannot go into 53, so we actually have a remainder of 53. So our answer then is 64 remainder 53, which seems pretty outrageous, but again, we're finding it with remainders instead of decimals this time with 2-digit divisors. And so we can see that our estimate again was close, but it wasn't spot on. So our final answer here is 64 remainder 53.
Okay, on this problem, I want you to show your answer as a remainder, as a fraction, and as a decimal, so you know how to do all three. Alright, so my first step is I'm going to use my rounding technique a little bit, and I'm saying basically we have 20 into 1,000. Okay, so when I look at my first three numbers there, I know 20 goes in there 5 times to 100. So I'm going to try 18 times 5. Now it may be 6, but let's see what we get. 40. Oh, that equals 90. Alright, that's going to be large enough. So I put my 5 over my 106 because we were checking how many times will 20 go into 100, and we said 90. When we subtract, we get 16. Now remember, always check when you subtract to make sure that this number is smaller than your divisor, and it is. Then you can continue on. If it's larger, we should go up 1 with that number. Instead of 5, I should have tried 6. Alright, bring down your next number. So now we have 18 into 161. Again, think of my estimate. 20 would go in there 8 times. Well, 18 is smaller, so we know at least 8 times, possibly 9. So I'm going to take 18 times 8, which is 64. Carry the 6. 8 plus 6 is 14. 144. Well, I have to check my subtraction, but I think we're okay here. We would subtract and have 11 minus 4, which is 7. 5 minus 4 is 1. I get 17. Now, you can see this is what happens. You get to checking to see if it's right, and I forgot to write the number that I multiplied by up here. So it's really important to see them right over the numbers so I can see that that number is missing. Sometimes I see students do their work and they have 5 for an answer where it should be 58. Okay, now to show our answer as a remainder, we would say 58 remainder 17. Okay, that's the easiest one. Now to show it as a fraction, I would say that's 58 with 17 as my numerator, and I use my divisor 18 as my denominator. So 58, 17 18ths. Okay, to show this as a decimal, I would take 58, and then I'll tell you it's probably okay. Long division, there's a lot of problems. So what I'm going to do is I'm going to take my calculator and I'm going to divide 17 divided by 18. And I'll tell you what I got. I got 0.9444, and it always goes on. So I'm going to write that answer as 58.94, and I put a line only over the 4. You only put a line over the top of the number is repeating. The 9's not repeating, only the 4 is. Sometimes you might have 2 numbers repeating, like it could go 0.85, 0.85, 0.85. If that's the case, then the line goes over both numbers. Okay, so there is one division problem. I showed my answer with the remainder, I showed my answer with the fraction, and I showed my answer as a decimal.
Alright, ladies and gents, you're ready for your ticket to class. As you may see, we have a challenge for you. Here we have a 3-digit divisor. Now remember, we've taught you how to do it with a 2-digit divisor, and you really have to take your time. So when you try it with this 3-digit divisor, again, take your time, use the guess and check method, and double check your work when you're finished. Good luck!